So this is, what year is this? 2006. Question 9, yeah. Let's say, so we have like P less than or equal to Q less than or equal to R primes, yeah. And we want to find the PQR times P plus Q plus R. It's a perfect square, yeah. And we want to find the biggest value of P plus Q plus R. Yeah. Okay, so I haven't quite gotten this answer, but I can tell you basically how to get to the answer, you know. So yeah, I was wondering if they had to be positive, if it affected anything. Maybe we can think about that later. And let's assume that they're positive now. Okay. So basically, can you see, because R divides, so the idea is R divides A, right? Squared. So therefore R divides A. So therefore R squared divides A squared. Yeah? That's what we're talking about. So R squared divides A squared. So it's clear that R divides A squared, right? So R has to divide. So another R has to divide this. So R has to divide P plus Q plus R, right?
Yeah.
And because R is prime, that means R has to divide P, R has to divide Q, or R has to divide P plus Q plus R, right? See, if R divides P, then because P is prime, they're equal, right?
Mm-hmm.
So, so this is like, so this is R equals P equals Q, right? Because Q is in between, and we said that doesn't work, right? Because you get 3p cubed, 3p to the 4 equals a square number, right? But there needs to be another 3. So this doesn't work, yeah? If R divides Q, so in other words, R equals Q, right? So we can assume R is not equal to P. So P is not equal to Q, but Q is equal to R. So that's what happens here, yeah? Yeah, so that's like PQ squared. Can you tell me what that is? P plus 2Q, right? It's a square number. So, but basically P, so this Q squared is like a Q squared, right? So this is still a square number. So for this to be a square number, there needs to be a P squared, right? It needs to be a P squared. But like, there's a P here, so P has to divide that. So P has to divide 2Q, right? So this is a problem if P, so this forces, see, P can't divide Q, right? So P has to divide 2. Does that make sense?
Yeah.
So P has to equal 2. You know? So if P equals 2, then what do you get? You get 2Q squared 2 plus 2Q equals a square number, right? Yep. Yeah, so that's 2 squared Q squared outside of Q plus 1 equals a square number. So Q plus 1 has to be a square. Yeah? So q has to be 1 plus. So what squares are 1 plus a prime? For example,
8.
So what are some squares? So let's see. 1, 4, 5, 16, 25, 6. So 4 is one of them, yeah? Right?
Yeah.
So q could be 3, yes?
Mhm.
So q could be 3. And if q is 3, then r is 3, yeah? Then p plus q plus r is equal to 8, yeah? Okay. I mean, what other squares are? There has to be these even ones, right? Because the odd ones are not going to be working. 9, 64, 63 is not prime, right? Yeah, okay. So obviously there's a better way to do this actually. So for example, you could write q plus 1 equals x squared or b squared, right?
Yeah.
And then q equals b minus 1, b plus 1, right? So that basically means the q is 1 times q, right? There's only one way to do that. So b minus 1 has to be 1, or b plus 1 has to be 1, right? So b plus 1 being 1 doesn't really make too much sense. Okay, so b minus 1 is 1, so b equals 2, right? Does that make sense? So b minus 1 equals 1, so b equals 2. And then b plus 1 equals 1 means b equals 0 and q is minus 1. So it doesn't make sense.
Yeah.
So all the other squares don't work. Yeah? So this is the only value so far. And then the last case here, right? If you look at this, so if r doesn't divide q, it means r is not equal to q, r is not equal to p, but it divides this, yeah? So obviously it divides r. So it has to divide p plus q, right? But how can it divide p plus q? Well, p plus q can't be 2r, right? Because if it's 2r, then p and q are both r. Do you agree? Yeah, so basically it can't be 2r, so it has to actually be r.
Yeah.
Okay? And it can't be 0 because we're assuming they're positive.
Yeah.
So p plus q equals r, right? But that's already kind of weird, right? Because usually primes are odd. Odd plus odd should be not odd, right?
Yeah.
So that means one of them has to be even.
Yeah.
It shouldn't be 2 because 2 is the biggest, right? It should be the smallest. So 2 plus q equals r, right? So basically this will lead to a contradiction, I think, because you have what do you have? You have 2 plus q equals r. So you have 2r. So this is 2r, right? This is r, and this is 2, right?
Yeah.
So that's already a square, and then we have a q left over, yeah? Does that make sense? So that's a problem. So I think this is the only one that could come out. Does that make sense? Yeah. How much sleep do you get these days? You get enough sleep?
Like 6 hours.
6 hours. How come so little?
Like 2 hours last night.
Oh, why?
I did it in the morning.
Oh, that's right. Good. Oh, but usually you need 8.
Yeah.
So that's really important. What time is it now?
40.
So can you tell your mom to come at 9?
Yeah.
She already knows. What was the other question we did? Which one was it? 2000 and 11 or 12. Yeah. So 2012, question 7, yeah?
Yeah.
2012, question 7. What's this one with x, y equals 2 x plus y, yeah? And this one?
Do you know do that?
Yeah. I just kind of want to summarize. And then it was like, so these x, y, z are real, non-zero real numbers, yeah? And determine 5x plus 7y plus 9z. Okay. And actually, in this case, we can actually determine x, y, and z separately.
Yeah.
But they didn't turn out to be integers, so that's why the question is asked for something like this. Yeah, so the approach that you came up with was really good. So one way was to solve x equals something in y, right? So it was like 2y on y minus 2. And then you did the same for y in terms of z, right? And then put 3z on z minus 3. And you did this, and then you did the last one for x, right? You equated these two, and then you subbed that in, and you solved for x. You solved for z, right? And then you solved it. Okay, that's really good. So that's good, and it's for some reason it's hard to see this in this context because it's like you're thinking of non-standard stuff, even though this is like sort of like a standard way of doing it. You know what I mean? Because in this test, you're expecting not to do it the standard way, but the standard way works, right? But I thought it was still interesting to make a comment of how we could do it if it was relative to stuff we knew, right? So we actually saw this equation only moments ago in the other question because it came from that question, I think it was question 10 in 2000, right? Where we had a half equals 1 on x plus 1 on y, right? And that gives you that equation. So the same thing will give you 1/3 equals 1 on y plus 1 on z, and 1/4 equals 1 on z plus 1 on x, right? And so I think the reason why this is interesting, because this looks much more standard and easy to solve, because you've really got just like, you know, x plus y equals a half, y plus z equals a third, and z plus x equals a quarter. And as you say, you can just add them all, right? So if you add them all, you get 2x plus y plus z equals a third plus a half plus a quarter. So you can put these all over 12. So it's 6 plus 4 plus 3. That's 13 over 12, no? Right.
Yeah.
And so this is 3 over 24. And then you said you can subtract 2 of these to get the third, right?
Yeah.
So subtracting a quarter from this will give you x. Will give you y, yeah? So
I can do that.
this is 13, right? It's 13 over. So subtracting this, which is z plus x, right? Will get you y. So y will be 13 minus 6 on 24, which is 7 on 24. Yep, and because little y is 1 over big Y, it'll be 24 over 7. So can you see this is also a really quick way to solve it? Okay. And this is interesting for us especially because you know, it's relative to something we did, right? So we can increase that. Yeah. Oh, by the way, was it really easy to show that? Because I remember this was also a case that we did. Is it really easy to show the answer is what it is? Yeah. So maybe I'll make a note of this. I won't go through it. Huh? What?
Okay. So good.
I won't go through it, but I'll make a note of it. So you can see how like weird 2012 can be for 2012 question 8. So 2012 would be very strange because all these questions that we did in previous years really help you do the 2012. So question 8 talks about a trapezium. Okay. And notice how similar the situation is to the other situation. Question 9 in 2000. I don't think we can expect this, but you know, who knows where you might have seen a similar question, right? So the whole area is 225. And the area of BPC is 49, right? What is the area of APD? So I'm going to call it Y actually because that's, remember that. And so basically we have from our question before, right? The whole area is given by 225. Remember, if that was X, it was X plus Y plus 2 root XY, right? And X was 49. So we're trying to figure out Y plus 14 root Y, yeah? And was this easy to do?
Yeah.
What's 220? That's 15 squared minus 7 squared, right? That's 8 times 22 equals root Y outside of root Y plus 14.
So you substitute and you substitute square numbers since y is to be a square number. You substitute.
Yeah, it's a quadratic though as well, right?
Mm.
So you could just solve the quadratic, but substituting also could be quick as well, right? only one answer works.
Mhm.
Apparently, only one. Is it clear only one answer works?
64.
So you need to get this 8. So you can
8
try
plus
64,
22.
and then you get 8, and then 22. Yeah, good.
Yeah.
Excellent. Yeah, so that was interesting. Yeah, I guess we can start some more, but we're not going to be able to go over the answers today. Yeah.
Mhm.